Hi everyone, my name is Wasila Rehman and I am recording my video for the data analytics project. This is a project that I have created on project number 1, Kafka Spark Streaming, and my goal was to use hard data and figure out some analytics that will help doctors in the future. So first I'll begin with my container and then I'll start pulling it. I'm in the directory where I have stored my folder, and then in the root directory I'm going to go for docker compose up -t. And as you can see, I've already run it, so it's already running in the background, so you'll see it's up to date and everything is perfectly fine. um, Next, we are going to move on and open our notebook for Zeppelin, and it's hosted on localhost 8080. As you can see, I've already run this notebook, so this is how I'm going to explain from here. In Zeppelin, in my root directory, you can see that I have stored a data set heart underscore 2020. This is a CSV file and the data set was taken from Kaggle. It has around 18 columns and some 3 million rows. It's a big data set, and so that's why I've chosen it, because it needs some implications as well, which I've tried to solve with this project. It has these columns including patient ID. Then it has heart disease, which is basically a categorical data set, whether a person or patient has had heart disease or not. Then it has some integer variables like BMI, physical health, mental health, age category, etc., and some string variables. So for my data set, I wanted to pick a few variables only and map them, because those variables are the most important ones. So now we'll see what dependencies we have downloaded. The first thing we had to load was Kafka Python in the shell, in Zeppelin shell, and then some more dependencies, including repositories from Maven, such as Spark Streaming, Hive, because I've used Hive databases in my project, and some Kafka assembly, and just updating the versions. So all you have to do is run this, and you can see that it was run by me a while ago and it took some 50 seconds. So this is working. Next step is to run Spark dependencies. These Spark dependencies again include Hive JDBC, Hive service, and Hive exec jar files. And then we need to download the producer dependencies, which are again the similar ones, and same goes for consumer dependencies. So these are the dependencies that I've already run a while ago, and here I have loaded my producer. So in my producer, I have chosen a Spark read format, and it's reading in CSV format using Databricks. It is basically uploading this schema for me, and this is where it's loading. This is the path file from where it's loading the data set from. So this is the big data set. It's only showing the first 20 rows, and this is the root file. This is basically the schema, and as you can see, there is integer, string, integer, and all of this is correct. Next, I'm going to run my producer. So I'm going to rerun this one, and in my producer I'm basically explaining what Kafka brokers are here. I'm assigning values to the input topic, which will be sent basically, which will be used in producer.send code of this pipeline. And then here you can see that we are basically assigning keys, which is like patient ID, in the data set, and then we are dumping these JSON values in our producer.send code, and then you can see that we are also returning the row dictionary. So I'm going to run this code, and then it will take a few seconds, and then we'll start running. Okay, so as you can see, this is running, and it's gonna keep on running until and unless it runs out. The time is out. Next, we are going to run our consumer code. So in my consumer code, I have imported some PySpark contexts such as Spark Session, Hive Context, and Kafka Consumer. It is basically building a session by app name Heart Diseases, and in that session, it's gonna load a couple of things. This is my major Kafka consumer code, where it's basically consuming the code that is being sent by the producer, and for each message in this consumer code, it's gonna create a row in the data frame that will be used forward to be stored in Hive. So basically, producer is running. It's you can see it's running over here. It's gonna send code to my consumer. Consumer is gonna consume that message, and it's gonna input all those values inside my data frame. Now, instead of mapping only a few columns of the actual data set, I had to use spark dot create data frame, and you can see this spark value is being called from this spark session. I had to enable the Hive support because I'm using Hive tables in here. And then once it's creating the data frame, it's gonna write it in the table. This command is used by Hive, and it needs this enable Hive support, because without it, this code will not work. Once it's writing it down in the table, so here, this is the database that I have created just over here, heart underscore db, and then it's going to store table underscore one in here. And then I'm creating a data frame that's being created by selecting all the values from this table. Next up is just some configurations for Kafka Consumer. Again, you can see that producer PySpark is running fine. We are going to run our consumer.pyspark. So it will take a couple of seconds, and then it will start printing out every batch of data frame that it will be creating. Sorry, every batch of the table that it will be creating inside Hive. Okay, so after 3 minutes, you can see that our consumer has started pulling out data, and it is showing all the data that it is storing in this format. So it's constantly producing that data, and it's consuming it from the messages that are being sent from the producer, and it's mapping it in the data frame that we have specified over here, as you can see. Now this table is being stored in, so in my configuration file docker compose, I have explained and I have created these Hive volumes, so everything will get stored in it. I've also specified the Hive Postgres URL in here. So everything is pretty much automated, and once I run this code, the file is going to get stored in this path that I have specified inside Zeppelin. So as you can see in my data drive path, there is table underscore one that we just created inside our consumer code, and it's getting appended. So in the mode append, it's gonna store everything. And now you can see that output is truncated because Zeppelin interpreter has an output limit. So it's still appending, and it's not like this has stopped working. It's appending, and you can see that the producer is also working for the past 7 minutes. Now we are going to pull the data from our Hive, and here we are using Spark. Once we will pull the data into a new table so that we can access it for our analysis, we can see that it's going to take some time. Okay, so now you can see that we have pulled the data in like almost 2 minutes, and it's created in the form of a Hive context. Next up, we are going to do some analysis on this data. The first query that we are going to run is a very basic query that we are just selecting patient IDs and heart diseases where sleep time is less than 10, and then we are ordering it by the patient ID. So you can see that it has printed out all the output for me over here for all the people who sleep less than 10 hours, and most of them do not have heart disease. um, Next, we are going to run this code where we are going to figure out what is the average sleep time of heart disease patients. So in my code, I have actually stored this. I have actually created these logics where it explains and specifies that heart disease is equals to yes and sleep time is less than 8. We can also try something else and just keep sleep time and not give any other query in terms of like along with heart diseases. And then we are going to group by it by age category because we want to see what is an average sleep time of all the people, all the patients who have sleep time less than 8 and are also heart diseases, because we wanted to see that the data was very skewed towards sleep time higher than 8 hours. That's why we kept this query in here. And as you can see from the output that it's mostly the people in the age group of 70 to 74 who have the highest heart disease count for this query, and their average sleep time is around 6.15 hours. um, so let's just remove this and see if our data changes, which it will obviously, but let's see. And as you can see, for age categories where patients having heart diseases, you can see that ages within 80 or 80 older have an average sleep time of 7.5 hours. And even then, the count is very high for heart diseases, which means that it's better if patients or people who are coming in this age group are sleeping more than this hour specified in here. So this could be a prescription that a doctor can provide to patients. Next up, we are going to see which age category, how many distinct age categories are present in here. Initially, I wanted to basically replace these values with some median of the ages. However, it's not possible inside Hive tables, so that's why we had to just stick to these string values for age categories. So now here we are going to run this command where we are basically trying to gauge so here we are going to basically gauge how many heart disease patients are there basically based on age, and we want to see if there is a correlation between ages and patients. And as you can see that there is a correlation. As our age categories are increasing, you can also see that the count of patients having heart diseases is also increasing. So the older you are, the chances are that you will have heart disease. And this is something a sign of concern, because if there is a patient, doctors can easily diagnose that whether the possibility of them having heart disease is super high or it's something that can be cured with medicines. um, Next, we are going to run this query. In this query, we want to figure out the average BMI of heart patients and also along with their age categories and the count of heart diseases. Basically, we want to see that what's happening when with the BMI and whether it's correlated with the possibility of higher heart diseases in any age category. So we are going to run this command and see what the outputs are. As you can see, I am grouping it by age category and I'm ordering it by BMI. Um, so here is the output, and you can see that inside my output, the BMI is actually increasing as the age categories are increasing, except for people who are within this age group. Because 80 or older, the BMI is very low again, and you can see that there is no such huge correlation between average BMI and the number of people having heart diseases within a specific age category. You can also try with between some ranges of the average BMI and check the number of patients who are showing up, and then you might even, as a doctor, you might even want to ask them to show up for their health checks or something like that. So this query is very useful in figuring out when to contact patients and how urgent is the treatment required. Next up, we want to gauge that is there a correlation between the gender and the number of people having heart diseases. So as you can see that the number of females having heart diseases are around 11,000 and males are around 16,000. But it could be possible that the number of patients, the data present in our data drive was biased and had more number of males. That's why we are going to check. So we are going to check whether it's true. Let's remove this part from the code and let's run it then. Okay. So as you can see in here that the females present in our data set are around 160,000 and males present in the data set are around 150,000. We can see that the percentages, the data set is not super biased. The number of people available is like it's a fair balance. So this number actually means that the correlation is high because males having heart diseases have like a higher chance of heart diseases, whereas females do not have a higher chance of heart diseases. So that's it, guys. This is how you can perform analysis. You can create data frames and then basically perform and build a front end through it. But I was unable to build it because of some configuration issues and the ports not working. That's why I was unable to build the front end. However, it's pretty straightforward after this. I've tried it, but I wasn't able to work it out. So this is my final presentation for the project, and you can see everything is stored in here. I have also added my report inside this Kafka Spark Stream folder. So thank you.